Hey guys, how's it going? Hopefully everybody's doing good today. I am going to be doing organic chemistry for Science 30 this week. So when I talk about organic chemistry, I'm talking about anything that contains carbon and hydrogen. So like C6H12O6, right? So this is organic because it contains carbon and hydrogen. Right? And you guys should kind of recognize that this is glucose. So this is a sugar. You find it in like oranges and we eat it. And within this glucose molecule, okay, well, that's supposed to be like energy. So like it's supposed to be energy in here. There's stored chemical potential energy in this compound, right? So that is what we're talking about. We're talking about organic chemistry, and that means anything that contains carbon and hydrogen is organic. So like this probably wouldn't be because there's no hydrogen in it. Okay, now if we look at your book, you guys have to learn how to name organic compounds. Now, naming organic compounds is actually not that difficult. But what you guys need to do to name organic compounds is you need your data book. Okay, so you need to look at page 9 of your data book. And page 9 of your data book has all these different compound names. And today I'm just going to teach you how to name alkanes. Okay, so you're going to name alkanes. And what is an alkane? It is carbon plus hydrogen, and there's only single bonds, okay? So what would that look like? Well, hey, is this only carbon and hydrogen? And is this only single bonds? Hey, carbon, hydrogen, single bonds, right? This is an alkane. That is what an alkane is. Now you gotta name this alkane, and you can use your data booklet to help you. Because if you see this part of your data booklet, it'll tell you the names. Okay, methane, ethane, propane, butane. You can see methane has 1 carbon, ethane has 2, propane has 3, and hey, butane has 4. Well, hey, look, this is 1, 2, 3, 4 carbons. The name must be butane. And there you go. You've just named this alkane. And the same thing would go if it was like C, C, C. Hey, there's another alkane. What would be the name? Well, there's 3 carbons, so I would name it like this, propane. Okay, so there you have it. Now, it gets a little bit complicated because you got to name, what happens if I give you this? Okay. Okay, well, if I give you this, right, all I can see, right, is I see 1, 2, 3, 4, 5 carbons. So I'm like, oh, well, what's 5 carbons? Okay, and if I draw these dashed lines just mean there's a hydrogen attached to it. I just don't write out the hydrogen every time because it's like time consuming, but just assume every time I draw a dash that there's a hydrogen there, okay? So anyways, if you take a look at this, you'd be like, hey, that must be, hey, propane, because there's 5 carbons. But that's not how you name this. You got to take a look at this compound, and you got to take a look, and this here, right, is what I call the parent chain that I drew in green. The parent chain is the longest carbon chain. That's the parent chain. Okay, and then this that's coming off the parent chain, this that's coming off, this is called the branch. Okay, now how can I tell the parent chain from the branch? Well, the parent chain is the longest carbon chain that's attached to each other. So like, for example, I see these 1, 2, 3, 4 carbons. They're attached to each other, 1, 2, 3, 4, in this carbon chain, right? But if I was to make this the parent chain, and I was trying to go, hey, let's see, 1, 2, hey, this carbon is attached to this carbon, so this could be carbon 3. Well, that would make this chain with each of the carbons attached to each other. This carbon's attached to this carbon, and this carbon's attached to this. 1, 2, 3. That's how long this chain would be. But if I go straight, 1, 2, 3, 4, where this carbon's attached to this is attached to this is attached to this, that's 4 carbons, right? It's not like this is attached to that and that's attached to that. So that's how you name. This is really important in naming, because the parent chain, right, will be the name that's given to you here. So the parent chain is the longest carbon chain, and the name of the parent chain is butane. Okay, now the branch that's coming off of that chain, right? Well, it tells you, okay, that it shows you here actually, like you can see, like if I number this 1, 2, 3, 4, that the branch is actually found on which carbon? It's found on the second carbon. So what I do is I say, okay, this is then called 2. Well, this branch has only 1 carbon on it, right? You can see there's only 1 carbon, so I take a look at my table, and 1 is F. Okay, now if you're a branch, you have to put the ending YL. That's what the branch's ending is. Okay, so the parent chain, which is the 1, 2, 3, 4, is butane, and the parent chain is ending in the ane, right? That just tells you that's carbon and hydrogen, single bonds, right? That's what butane means. And then the branch has to end in YL. So what would this be? Well, because we're only dealing with 1 carbon, and the prefix for 1 is meth, I call this 2-methyl butane. Okay, why 2? Because 2 is where the methyl is branching off. Why meth? Because I'm dealing with only 1 carbon, right? Why YL? Because the YL indicates that's the name of the branch. And then the parent chain is this butane. Okay, we're going to do another one and make sure everybody gets this. Okay, so here I have another chain. Okay. Okay, now if I take a look at this chain, I'm going to try to figure out what the longest parent chain is, okay? I'm going to always try. So the rule is always try to figure out the parent chain first, okay? Parent chain first. So here we go. 1, 2, 3, 4. If I went that way and made that my parent chain. I don't know if that's correct or not, because if I go 1, 2, hey, 3 this way, I could make this the parent chain, but I don't know. Is there a longer chain there? Hey, let's try 1, 2, 3, 4, 5. Hey, I just found the longest chain. That's the longest chain with 5 carbons attached to each other. So now I just found the longest carbon chain. So what I'm going to do is I'm just going to sort of redraw this quick, right? Where I had a carbon here and a carbon here. And this is what my compound looked like. And remember, each of these branches represents a hydrogen. So what I just did was, right, hey, this is 1, 2, 3, 4, 5, right? That's a 5 carbon chain. Okay, so this becomes my parent chain. And how do I name my parent chain? Well, I look at my data booklet and it says that it is pentane. Okay, so the parent chain, which I named first, it's going to be pentane. Okay, that's the name of my parent chain. Now let's take a look, because I see a branch here and a branch here. I see 2 branches, right? Well, what's the name of the branch? Well, I know that the branch, so you got to name the branches next. And they end in YL. Okay, so here's a branch and here's a branch. So guess what? If I was to name this whole thing, I would name it like this: 2, 3, because I see a methyl on the number 2 carbon. I see another methyl on the number 3 carbon. Okay, and then I would write this as being dimethyl because I'm dealing with 1, 2 methyl groups. 2, 3, dimethyl pentane. Okay, that's the name of the parent chain. Dimethyl, di means 2, okay? And if you want to know what the prefixes are for, like, mono is 1, di is 2, tri is 3, tetra is 4, I call it dimethyl because I'm dealing with 1, 2 methyls. And these are where the methyls are located. And there you go. That's how you do it, right? That's how you name organic compounds. Now, well, that's not how you name all organic compounds, but that's how you name alkanes. I'm hoping that you guys kind of understand this a little bit, like how I just did it. There are some practice problems that you can try, right? So like right here, if you take a look at organic chemistry, what would be the name of this? 1, 2, 3, 4, 4, and there's no branches, so the name is just butane, okay? They're saying that you could either draw it like this, or you can like condense it or make it short. You can see this carbon has 3 hydrogens attached, so it becomes CH3. Well, it should say well, I think maybe I'll just add that in. So this would then look like CH3, CH2, CH2, CH3, like that, okay? So that would be the condensed version. That's what it would kind of look like, and you're never going to see it drawn like that, so don't worry about that. All right, so then it asks you to draw these 2-methylpropane, right? So I want you to try that. You don't need to do this line diagram, right? 2-methylpropane would be, okay, if I want to draw that, well, propane is my parent chain, and propane is 3 carbons, so my parent chain is 1, 2, 3, that's propane. And it says on the number 2, 1, 2, 3, there's a methyl, so then I draw a methyl, and there you go. That's all you do. So draw the parent chain first and then add your branches. And there you have it for that, okay? So I'm hoping that you understand this, okay? You don't need to know how to name that, alkenes and alkynes. We don't do that. So we're now gonna go to benzene as our next lesson. Very quickly, benzene is very stable, so I'm just gonna show you, you're gonna see it. This is an organic compound. So every time you see this, it's a carbon like that with a hydrogen attached to it. So each of these carbons has this hydrogen attached to it. And you can see that this is in a ring. And when I draw a line here, that means this carbon and this carbon, there's a double bond between the 2 carbons, right? Now, because this is a ring structure, because it looks like a ring, it is very stable. Okay, so it's really hard to break this down. And the problem with this is what plastic is made up of. And so if you ever ate plastic, this would be what you're consuming, and you wouldn't break it down, and it would stay in your body, and it could be very, very toxic, okay? So we do not want to eat benzene. We do not want it to enter our food chains. We do not want it in our oceans and animals to ingest it. This thing is extremely stable. You can't break it down. It will persist in your body. It's called a persistent organic pollutant. Okay, you also find benzene rings if you cook your steak and it's like black on the outside because you char it. That is benzene ring, and again, that's cancerous. Not good for you. Don't eat it. Okay, I'm going to stop here for now, and I'm going to upload it and give you the next lesson. Okay, bye.